You are probably aware that air tools have many advantages, or if you like, pros. Some of these are things like they are inexpensive, tough, easily serviced, powerful, and they last for years. But they do have one big drawback or con. They require a compressor to power them that matches or is greater than their rated CFM. Which means not all compressors will run all air tools. So, what to look for in a compressor? Should we look at the maximum PSI of a compressor? For common air tool use, really, don't focus too much on the maximum pressure, okay? So what is PSI? Well, PSI is an acronym for pounds per square inch. And when it's related to compressors, it's used as a measurement of output. The max PSI is not really important when choosing a compressor to power air tools, because most air tools are test rated at 90 psi. That's an industry standard. And if you haven't already noticed, almost all new compressors have a maximum PSI rating of 120 or more. But there is one benefit to having higher pressure in an air tank. It allows air tanks to hold more air without increasing the tank size. Here's an example. 150 psi in a 2-gallon tank is the same amount of air as 100 psi in a 3-gallon tank. Now we have tank size. What size tank is needed? The capacity of the tank really does count, especially for extended use tools like spray guns or cabinet bead blasters. Tank size is important and it can be tied to the duty cycle of the compressor pump. We'll discuss more on duty cycle later. Having a large tank gives you longer operating time before the compressor cuts back in to refill the tank. Using high volume air tools on a small tank compressor often makes the compressor run continuously, like spray guns, not good for many compressors. Tank size also affects the severity of pressure drops, again especially noticeable on high volume air tools. Large tanks are good for sanders, spray guns, grinders and air hammers, while on the other hand small tanks are more suited for staplers, brad nailers, some nail guns, riveters and tyre inflators. Horsepower. Probably one of the most noticeable specs plastered over a compressor. If you are looking at horsepower, only look at the running or the rated horsepower, not the peak. Although it is one of the most noticeable specifications, horsepower is of little importance here. As a rule of thumb, the bigger the horsepower, the more CFM. In most cases, the manufacturer of the compressor will match the motor and the pump unit to achieve optimum performance. Okay, horsepower can be an indicator of the power supply needed to run the compressor, if not visibly stated, although some motors are dual voltage. 3.5 horsepower is close to maximum on just about any domestic power supply, that being single phase. 3-phase power is used with bigger horsepower motors because it's more energy efficient than single phase. CFM. What's the maximum air volume required? This is also known as CFM. Here's a hint, look at your air tools. When it comes to compressors, CFM is king. Air volume produced is measured in cubic feet per minute, CFM for short. Now CFM is key to choosing the right compressor for the air tools you use. Every air tool you use has its own rating in CFM, just like compressors. Most air tools rating is obtained while being tested at 90 psi. Now this next piece is important. Your choice of compressor should be based on the air tool you use with the highest CFM. I'll give you an example. If you had a brad nailer rated at 2 CFM, an impact gun at 6 and a sander at 11 CFM, your required compressor is 11 CFM plus 30% margin. Based on that example, your compressor should have at least 14.3 CFM. But if you have 2 air outlets in use at the same time, then it would be the combined total of the air tools plus 50% margin. Something you should also know, many air tools like impact wrenches are rated by average use. The 6 CFM rating of a half-inch impact gun is based on an average use of about 15 seconds. In reality, rating an impact gun for a full minute would put its CFM usage up at 20 plus. Duty cycle of a compressor. Originally, I was going to leave the duty cycle out because it's not often mentioned or plain to see what it is. If you are considering buying a compressor and putting it to hard work, you really need to know about the duty cycle of the compressor. To find out the duty cycle of the compressor, you'll have to call the manufacturer or talk to a salesperson. That is unless you understand the code some pumps have on the specification plate. Which I think is wrong, because duty cycle ranks right up there beside CFM and should be made clear like all the other specifications. The term duty cycle refers to the percentage of time an air compressor can run before needing to cool down. By the way, this is mostly related to piston type compressors, not the rotary type. Here's an example using a 10-minute cycle. A 30% duty cycle equals 3-minute runtime in a 10-minute period. Air compressor can run for 3 minutes, then needs to rest for 7. A 50% duty cycle equals a 5-minute runtime and a 5-minute rest. A 100% duty cycle is continuous running. Some manufacturers use a 1 hour as the duty cycle period. Does the compressor need to be portable, mobile, or remain stationary? Mostly this will depend on your primary usage, like the air tools you want to power and where they will be used. Being portable is not limited to small carry compressors, it can stretch to larger wheeled ones, and stationary compressors can be mounted to vehicles. Depends on your definition of portable. Builders, carpenters, mobile mechanics and paint touch-up services are some that use portable air compressors. While home engineers, woodworkers, mechanics and car detailers often require larger, less portable compressors. Many large horizontal compressors have wheels, making them mobile. But even with wheels, some of these compressors can be very difficult to move. Many of the cheaper portable compressors, and some of the big ones, have oilless motors. These do have a tendency to be noisy and almost all are not designed for continuous operation. Now let's take a quick look at some common air tools, their average CFM and compatible compressors. Shown here is the average CFM of some common air tools often used with small portable compressors. These type of portable compressors are best described as being able to be carried by one person. Most compressors shown here are oil filled and only 2 would adequately run the 3/8 ratchet. Here are some common air tools that are often used with mobile and stationary compressors that have a CFM under 10. For garage use, this group is the most popular. They hit the sweet spot for price, versatility and CFM to power most air tools. The air tools shown here are air hungry. 3 of the tools are often used for a full minute or more, so the average CFM here can be misleading. You'll notice that on these compressors their rated CFM is measured at 100 psi or more. Remember, add 30% to air tool CFM to get the required compressor CFM. Taking care of your investments. Other than quality airlines, couplers and air tool oilers, there's one piece of equipment that should be installed with every compressor. A water separator, also known as a water trap or water filter. They come in various types and sizes to suit most applications. Small inline filters are usually fitted to the end of the air tool. Single wall-mounted water traps come in a variety of pipe sizes ranging from 1/4 to 3/4 inch NPT. Combination units come in a variety of configurations with oilers, regulators and desiccant dryers. That's it. I think compressors are a great investment. They have a multitude of uses and expand what anyone can do by using air tools and equipment. I also hope you found this short video helpful and now know enough to comfortably choose your new compressor.